Hello pre-calculus, it's time to start chapter 4, polynomial functions, starting with the fundamental theorem of algebra. The fundamental theorem of algebra is every polynomial equation with degree greater than 0 has at least one root in the set of complex numbers. A couple things to remember about that. Complex could be real or imaginary, and roots, the slightly confusing thing about roots is you can have double roots, but every polynomial p of x of degree n, where n is greater than 0, can be written as the product of a constant k, which is not 0, and n linear factors. So linear factors, remember, that means degree 1, or x to the first power. So if you have a polynomial of whatever degree, it could be to the 5th power, it could be to the 18th power, it's possible to break it down into its component factors. It's possible always to break it down to some constant, some number that is, and linear first degree factors. Thus a polynomial equation of degree n, so n is the highest exponent, has exactly n complex roots, namely root 1, root 2, root 3, root n. And each of those roots corresponds to one of the factors. Sorry, my glasses just spontaneously fall off. Each of the roots corresponds to a factor, x minus that root. So, here's an example of polynomial functions with positive leading coefficients. That just means if you have negative leading coefficients, they just go the other way. So if it's going up, it'll go down. If it's pointing up, it'll go down. Anyway, and degree greater than 0 displaying the maximum number of x-intercepts. If you know the degree of the function, that tells you something about the number of direction changes and therefore the maximum number of x-intercepts. A first degree equation has only one directional piece. It never changes directions, has no changes of direction, and therefore at most it can have one x-intercept. Actually, it pretty much always has one x-intercept, but there's no way to have more because once it's crossing, it's never going to change direction again. It'll go up forever. The degree 2 polynomial can only have one change of direction. It has two directional pieces. It only changes direction once, and therefore it can have at most two x-intercepts. It could have none if that change in direction is above the x-axis. If it's degree 3, I think you're getting the idea, 1, 2, 3 pieces, 2 changes of direction, and a maximum of 3 x-intercepts. 4th degree, 1, 2, 3, 4 pieces, 3 changes of direction, and at most 1, 2, 3, 4 x-intercepts. Degree 5, it goes 1, 2, 3, 4, 5. 1, 2, 3, 4 changes of direction, and 1, 2, 3, 4, 5 over here, x-intercepts. It doesn't remember that if the direction change happens above the graph, or above the x-axis or below it, it won't have an x-intercept there. So it can have fewer, it just can't have any more. If you have imaginary roots, you won't have as many x-intercepts. An x-intercept only occurs at a real root. So if you have an imaginary root, there will not be a corresponding real x-intercept. So this is a degree 3 equation that only has one x-intercept. The other two roots are imaginary. Again, one x-intercept, degree 4 with two x-intercepts, degree 4 with no x-intercepts. It still has 4 complex roots. It's degree 4, it has 4 complex roots, but in this case, they're imaginary and not real. So, sketch the general graph of a 6th degree function. Sorry for the rattling there. So, 6th degree function, let's see. It will have 6 directional pieces and 5 changes of direction. So, 1, 2, 3, 4, 5, 6. There you go. It's not pretty, but that would do it. If it was 7, I would have another directional piece. So 1, 2, 3, 4, 5, 6, and 5 changes of direction. And at most 6 roots, 6 intercepts. State the degree and leading coefficient. Okay, we saw this in the last chapter. The degree is the highest exponent. of your variable. And the leading coefficient is the coefficient of the term that has that exponent. So here, pretty simple. The highest degree, this is degree 3, degree 1, degree 0, because there's no variable at all. So the degree is 3, and the leading coefficient, well, here's the term that has that power, and the leading coefficient is 1. There's nothing in front of it, so it's a 1. Here, this is degree 2, degree 5, degree 0. So the whole thing is degree 5, because you go by the highest one. And the leading coefficient is the coefficient that goes with it, so 8. The reason we talk about the degree, and we're not really worrying about these lower degree terms, is the highest degree is going to govern the shape of the function. So this is a cubic function. It'll go like this, or vice versa. It may be a slightly different shape, but it'll have 3 directional pieces, it'll have 2 changes of direction, it has at most 2 x-intercepts. So that's what matters in terms of the graph, and the 5th degree, that's what matters in terms of the graph. The squared term will affect it, but it's not going to affect it as much as the highest degree. Determine whether each number is a root. All right, if it's a root, then it's an x-intercept, meaning if you plug it in for x, you'll get 0. So the easiest way to tell here is plug it in. So 5 cubed minus 5 times 5 squared minus 3 times 5 minus 18, 125 minus 5 times 25 is 125, minus 3 times 5 is 15, minus 18. That's negative 33. That is not equal to 0, therefore 5 is not a root of this function. 6, plug in 6 for x, 6 cubed minus 5 times 6 squared, minus 3 times 6, minus 18. 6 cubed is 216, minus 5 times 36 is 180, minus 3 times 6 is 18, minus 18, plug that in the calculator, that comes out to be 0, therefore yes, 6 is a root of this equation, of this function. Write a polynomial of least degree for each set of roots. So what we're going back to here is this. We're kind of going backwards here. If these are the roots, then you can turn them into factors. So if negative 5 is a root, then one of the factors of your function is x plus 5. If 7 is a root, one of the factors is x minus 7. Go ahead and multiply them. So my apologies, I just don't want to start over. X squared minus 7x plus 5x minus 35, or x squared minus 2x minus 35. Does the equation have odd or even degree? Even. It's degree 2. How many times does the graph cross the x-axis? Well, you can graph it and see it will cross it twice. Once when x is negative 5 and once when x is 7, so it crosses the x-axis twice. This one is going to be longer to do, but I'll show you how you can make it a little more simple. So the roots here are x minus 6. Imaginary roots always occur in pairs. If one of the roots is 2i, the other one has to be negative 2i. So if I tell you that one of the roots is 3i, I might not even say negative 3i. I expect you to know that if 3i, then also negative 3i. But x minus 2i, x plus 2i, x minus I, x plus I. So there are 5 roots here. You could sort of naively go multiply these two together, multiply the result times this, multiply the result times this, multiply the result times this, but it'll take you a really long time, and it'll get very confusing, and you will almost certainly make some mistakes. What you want to do is take these imaginary pairs and multiply them together first, because, among other things, that will always get rid of your imaginary terms, and all your terms will be real. So we're going to leave the x minus 6 alone for right now. If you do this, this becomes x squared plus 2ix minus 2ix, so that gives you 0, minus 4i squared. I'm going to leave that for right now, but we're going to change it in a minute. And then here, x squared plus ix minus ix minus I squared. So x minus 6. Well, what is I squared? I squared is the same as negative 1. So this is x squared minus 4 times negative 1, or x squared plus 4. Same here, I squared is negative 1. So this is x squared minus negative 1, or x squared plus 1. Then I'm afraid there's no way around it except to actually multiply them out. I'm going to take a shortcut, but feel free to verify this for yourself because you're going to need to get some practice with this. But you should get x to the 5th minus 6x to the 4th plus 5x cubed minus 36x squared plus 4x minus, ooh, I seem to have gone off the page. Well, minus 24. And I'm sorry that's such a mess. Don't have really enough room. We're still going to answer these questions. Is it odd or even degree? That's 5th power, so it's an odd degree, which makes sense. 1, 2, 3, 4, 5 roots. How many times does a graph cross the x-axis? Well, you can try this out by graphing it, but in fact, it will only cross the x-axis once at 6. This is the only real root, therefore it's the only x-intercept. All of these are imaginary roots, so they won't show up on the graph. State the number of complex roots, then find the roots. How many complex roots must this have? Well, the same as the degree. 2 of them. What are they? Well, there's a number of ways to solve this, and that's tomorrow's lesson. But it's all review. You've seen it before. You can factor it, you can graph it, you can use a quadratic formula. In this case, I'm going to factor it because it turns out to be x minus 7 times x minus 7, which means my roots are positive 7 and positive 7 again. There are 2 roots, but they're both the same. That's a little weird, but it happens. So the root here is 7. There are 2 roots and they're both 7. How many complex roots? 3 of them. Let's factor this. First we'll take out the a, because they are all multiples of a. A squared plus 2a minus 8. Then you can factor that. A times a plus 4, a minus 2. And then to find the actual roots, set each equal to 0. If this is 0, then a is just 0. If this is 0, then a is negative 4. And if this is 0, then a is 2. So those are the roots, 0, negative 4, and 2. And this one, t to the 4th minus 1 equals 0. There are a couple of different ways to go about solving this, but basically just be careful. A lot of ums here, sorry. I'm going to actually treat this as a difference of squares, right? If you've got, if this is a perfect square, it's a difference, and this is a perfect square, you can factor it into square root plus square root minus square root. Then, set each of these to 0. If t squared plus 1 equals 0, then t squared is negative 1, which means t is positive I or negative I. If t squared minus 1 is 0, then t squared is positive 1, then t is positive or negative 1. So there are 4 roots, number of complex roots. 4 complex roots. There are 4 complex roots, positive I, positive 1, and negative 1. And that's it.